Hi, I'm John, and this is my video about .NET. In this video, I'm going to be running through the fundamental concepts of the .NET platform. We're going to be looking at a timeline and history of .NET, dependency injection, middleware, configuration, the program.cs file, classes, and other fundamentals. So first of all, what is .NET? .NET is a free and open source developer platform provided by Microsoft. .NET has a long history in the .NET platform originally, and now more recently .NET Core, which has become known as just .NET. And it can be used to develop various types of applications, desktop applications, web applications, that are cross-platform, supporting Windows, Linux, as well as Mac OS. And it unifies the capabilities of .NET Framework and .NET Core from .NET 5 onwards. So originally we had .NET Framework, which was specific to Windows as part of what was built into Windows, .NET Framework. This became .NET Core, which is a successor to .NET Framework, and it was born in the cloud to be cross-platform, work across various operating systems, and eventually, after getting onto .NET Core 3, we then went to .NET 5, and the idea of this was that it was to unify the .NET Framework in .NET 5 onwards. The language is platform agnostic, and it supports multiple programming languages including C#, F#, and Visual Basic. So this is a timeline of the .NET Framework and .NET, which comes under the umbrella of the .NET platform. So originally in 2000, Microsoft announced .NET Framework 1.0, and originally this was a challenge to Java at the time. In 2002, we had .NET Framework 1.1, which provided support for building web services. We then had .NET Framework 2 in 2005, as well as Visual Studio 2005, which is an integrated IDE for developing .NET applications. In 2007, we then had .NET Framework 3.5, which introduced LINQ, which is one of the things I'll be going through in this presentation. And then 2010, we had .NET Framework 4 with other major upgrades. In 2012, .NET Framework 4.5, which included async and await programming. In 2016, .NET 1 Core was released. So this was the very first new version of .NET, the successor to .NET Framework, and for several years we had .NET Framework and .NET Core almost running alongside each other, and then we went to .NET 2 and .NET 3, and finally in 2020 is when .NET 5 was released, just becoming known as .NET, so .NET Core this is. And this unifies the .NET Framework and .NET Core. So there's no more major releases now of .NET Framework. It's just .NET from now on. So another part of the .NET platform is ASP.NET, and this is a framework within the larger .NET ecosystem, and it's specific for building high-performance web applications and web APIs. It allows you to build modular, cloud-based and internet-connected applications. It's the evolution of the original ASP.NET framework, which came with .NET Framework and is now cross-platform. And this is for building web applications, web APIs and web sockets. So getting into some of the concepts of .NET, the first one is dependency injection, and this is a key concept in a range of programming languages, and .NET is no different. So dependency injection is a fundamental aspect of software engineering that facilitates better software design, and it promotes the inversion of control principle. It allows you to decouple the components of an application to be modular, testable and maintainable. And it allows classes to be less dependent on each other, removing hard-coded dependencies and instead allowing you to inject them. So you can see on the left here a comparison of using dependency injection and not using dependency injection. It can greatly reduce the code, ensure that you're not repeating yourself in the code as well. So why would we use dependency injection? Well, it allows us to decouple components, making the system modular. Simplifies mocking of dependencies, since we're injecting our dependencies when we're running unit tests and other kind of tests. We can mock these dependencies quite easily without any significant code changes. It's easier to make changes without affecting other parts of the system. Some of the solid principles, we find that by coupling parts of our system, a change in one part of the system can affect other parts of the system quite easily. So this avoids this. It's easier to swap out implementations such as database types. And then let's get into how. So the built-in dependency injection container allows you to register services and their implementations. So typically in the program.cs file is where we will register our implementations, which will then allow them to be injected into other classes. And this is done in the configure services method there. At that point, they can then be injected in controllers, middleware, or other services or classes in our project. Now, when we're registering dependencies in our program.cs file, we have several options for the service lifetime. We have transient, and this is a new instance that is created each time it is requested from the dependency injection container. So every time we call in that dependency in one of our classes or controllers, we're creating a new instance of that dependency. It's used for services that are lightweight, stateless, and need to be unique for every consumer. And data or state isn't retained between requests. So examples would be creating a logging service that appends a unique identifier to every log entry, or a fresh instance of the logger. A fresh instance of the logger is created for each request. The next service lifetime is scoped, and this means that a new instance of the service is created once per request scope. So typically once per HTTP request in a web application, and this is for services that need to maintain a consistent state within a single request. An example would be a web application with user authentication, and it allows us to store user details from the database for the duration of the request instead of hitting the database each time. So this is the benefits of a scoped request. And then finally we have a singleton, and this is one instance of the service is created and shared across all requests. The instance remains for the entire application lifetime, and it's for services that need to maintain state or share data across multiple requests across the lifespan of the application. Examples would include API keys or connection strings reused throughout the application lifecycle, and it's for when and it won't be changed frequently or used across multiple requests. So next we've got middleware, and this refers to software components that sit in the middle of a request response cycle. Middleware components are chained together to form a pipeline. HTTP requests and responses must pass the pipeline and go through each step in the middleware. Each middleware performs some operation, passes a request to the middleware, or short circuits the pipeline in certain scenarios. Examples include logging, error handling, authentication, static file serving, routing, and more. So looking more specifically at the request pipeline, middleware components are executed in order. They are added in the app's request pipeline. The pipeline is configured in the startup or the program class. Each middleware has access to the HTTP context and can pass it to the next middleware in the pipeline, manipulate the request, or terminate the pipeline early by not calling the next middleware. Middleware can have several actions, and this includes process the request and pass it to the next middleware, generate and return a response early without calling the next middleware, or perform post-processing on the response after the subsequent middlewares have executed. The next concept is configuration. And configuration provides a way for us to retrieve settings from multiple sources like JSON files, environment variables, command line arguments, and more. So in our application, we're going to have environment variables, an app settings file potentially, and these are going to contain values that vary in different environments. So take, for example, a connection string for a database. That's likely to be something that is different in each environment because dev, test, and production are going to have separate databases typically. So configuration provides us a way to retrieve these environment variables and use them in the application quite easily. And this is centered around the iConfiguration interface. iConfiguration is injected so that the settings can be accessed, so this would be in a class. A typical example, as I mentioned, is appsettings.json, and it allows developers to adapt their applications to different environments and conditions without changing their code. So the next concept is the program.cs file, and this is a key file in any .NET application, and it's a requirement of every .NET application as well. So this is where the .NET application starts running, and it plays a central role in configuring and bootstrapping the web application. And this is where we have the middleware and the declarations for our dependency injection would be held in this file. And examples include setting up application configuration source from input line, appsettings.json and environment, service registrations, host configuration, and application start. The next concept is classes, and these are a fundamental building block of .NET applications. They encapsulate data for the object and behavior in a form of methods, properties, events, and more. And they're a blueprint or prototype from which objects are created. Now, class is used interchangeably to refer to different things. Typically, it would be a blueprint for an object. So if we've got a user object, for example, we would have first name, last name, email address, and other information that we want to have in there. But it's also refers to a class of methods or controller. A controller is a type of class as well. So it's used interchangeably in that sense. So next we've got access modifiers, and these are keywords that set the accessibility of types, methods, properties, fields, and other members. So the ones that we've got are public, available anywhere in the same assembly or another assembly referencing it; private, only accessible within its declaring type; protected, which is accessible within its declaring type and by derived types; internal, accessible within its own assembly and not other assemblies; protected internal, accessible within its own assembly and also by derived types; and finally private protected, which is more restrictive than protected internal. Derived types in the other assemblies can't access the members when using private protected. The next concept is properties, and this is a fundamental aspect of object-oriented programming. Members of a class provide a mechanism to get or set the values of an object. We have the get accessor, which returns the property's value, and the set accessor, which assigns a value to the property. We then have interfaces, and interfaces are another key concept of programming. And this is a type of definition that specifies a contract. It defines a set of methods that a class or struct must implement. and it does not provide the implementation for the methods, only provides their signatures. So ultimately, an interface defines methods or actions or structs that are implemented in a separate class. So a separate class would inherit from that interface and implement the actual methods and the code that execute those methods. Next, we have methods, and methods are blocks of code that perform operations. They're defined within a class or a struct. They encapsulate behavior that can be executed by calling the method on an instance or of the class or struct, and they're fundamental in .NET for the execution of any operation. So finally, we have monitoring and logging. So monitoring and logging are crucial aspects of developing, deploying and maintaining .NET applications. So it's not unusual to have different behavior between when we're running our application locally and when we're running it in production, and monitoring and logging provide a mechanism to see what is happening to our application when it's deployed in production, diagnosing issues and ensuring the health and system performance. .NET provides a robust infrastructure for monitoring and logging built in, and we can leverage using built-in features or external tools, third-party tools that we can add to our project. There are several components to monitoring and logging. We've got loggers, which is components that create log messages. Log levels, so this might define how these messages are surfaced. They give them a criticality level: trace, debug, information, warning, error, or critical. Logging providers, and these are components that process log messages from loggers. .NET supports multiple logging providers, allowing logs to be written to various destinations. And then finally, we've got iLogger interface, and this is the primary interface that applications use to create log messages. That concludes my presentation on .NET fundamentals. Thank you for watching.